Mars had rivers, lakes, and maybe life. So what went wrong? Mars is the fourth planet from the Sun. It is about 225 million kilometers away from Earth on average. But the distance constantly changes because both planets move in their orbits. Mars is called the red planet because its surface is covered with iron oxide. Iron oxide is basically rust. So Mars is red for the same reason old metal turns red. Oxidation. Mars is about half the size of Earth. Its diameter is around 6,779 kilometers. Earth's diameter is about 12,742 kilometers. That means Mars is much smaller, lighter, and has weaker gravity. Gravity on Mars is only 38% of Earth's gravity. If you weigh 60 kilograms on Earth, you would weigh about 23 kilograms on Mars. You wouldn't float, but jumping would feel easier and higher. A day on Mars is called a sol. One sol lasts 24 hours and 39 minutes. That is very close to an Earth day, which is one reason scientists consider Mars one of the best candidates for human exploration. A year on Mars is much longer. One Martian year lasts 687 Earth days. That's almost 2 Earth years. Mars is much colder than Earth. The average temperature on Mars is about minus 60 degrees Celsius. At the equator, it can reach 20 degrees Celsius during the day. At the poles, it can drop to minus 125 degrees Celsius. Mars does not have oceans, forests, or cities. Its surface is mostly rock, dust, sand, craters. Mars also has polarized caps made of frozen water, frozen carbon dioxide, dry ice. Unlike Earth, Mars does not have a strong magnetic field. This is extremely important. Earth's magnetic field protects us from the solar wind. The solar wind is a stream of charged particles coming from the sun. It can slowly strip away an atmosphere. Mars once had a thicker atmosphere. But without a magnetic field, the solar wind gradually removed most of it. That is one of the main reasons Mars became cold and dry. Mars' atmosphere today is very thin. It is about 1%, as thick as Earth's atmosphere. Its composition: 95% carbon dioxide, 2.7% nitrogen, 1.6% argon, tiny amounts of oxygen and water vapor. This means humans cannot breathe on Mars. No liquid water can easily exist on the surface. Pressure is too low to support life as we know it. If you stood on Mars without a spacesuit, you would lose consciousness in seconds. Not because you freeze, but because the air pressure is too low for oxygen to stay in your blood. Mars has seasons like Earth, but they last almost twice as long. This happens because Mars' year is longer and its orbit is more elliptical. When Mars is closer to the Sun, its southern hemisphere experiences stronger summers. That is one reason dust storms often start in the south. Mars has one of the most interesting surfaces in the solar system. Even though it looks simple and empty, it has some of the largest geological structures ever discovered. The surface of Mars is covered in a fine layer of dust. This dust is made of very small particles of rock and iron oxide. That is what gives the planet its red color. Under the dust, the surface is mostly volcanic rock, similar to basalt on Earth. Mars is full of impact craters. Because it has a thin atmosphere, small meteors are not burned up before hitting the surface. And because Mars has no active plate tectonics like Earth, these craters stay visible for billions of years. Some areas on Mars are very old. They are among the oldest surfaces in the solar system. Other areas are much younger and show evidence of volcanic activity. One of the most famous features on Mars is Olympus Mons. It is the largest volcano in the solar system. Olympus Mons is about 22 kilometers tall, nearly 3 times higher than Mount Everest, about 600 kilometers wide. It is so large that if you stood at its base, you would not even see the top because of the planet's curvature. Olympus Mons formed because Mars has weak gravity and no plate tectonics. On Earth, tectonic plates move, so volcanoes shift position over time. On Mars, the same hotspot kept building lava in one place for millions of years. That allowed Olympus Mons to grow extremely large. Mars also has the largest canyon in the solar system, Valles Marineris. Valles Marineris is about 4,000 kilometers long, up to 200 kilometers wide, up to 7 kilometers deep. For comparison, Earth's Grand Canyon is about 446 kilometers long and about 1.6 kilometers deep. Valles Marineris is not a river-formed canyon like the Grand Canyon. It is mainly a giant crack in the crust caused by tectonic stretching when nearby volcanic regions formed. Over time, landslides and erosion shaped it into a massive canyon system. Mars also has vast plains made of hardened lava. These show that Mars was once volcanically active. But today, Mars is mostly geologically inactive. There are no confirmed active volcanoes. Mars has cooled down much faster than Earth because it is smaller. Smaller planets lose heat faster. Another important surface feature is evidence of ancient water. Scientists have found dried up river channels, valley networks, delta formations, minerals that only form in water. These structures strongly suggest that liquid water once flowed on the surface of Mars. Some valleys look almost exactly like river valleys on Earth. They have branching patterns, smooth curves, erosion shapes. This means water was not just present once, but flowed for long periods. Mars also has dried up lake beds. One of the most famous is in Jezero crater, where the Perseverance rover landed. Jezero crater contains a delta structure, layered sediments, signs of long-term water activity. On Earth, deltas are excellent at preserving signs of life. That is why Jezero is one of the main targets for searching ancient microbial life. Mars soil is called regolith. It contains silicon, iron, magnesium, aluminum, sulfur. It also contains perchlorates. These are toxic chemicals that make growing plants directly in Martian soil very difficult. Any future farming on Mars would require soil treatment, water purification, controlled environments. The color of the soil changes depending on location. Some regions are more brown, some more orange, some almost purple. Mars also has polar ice caps. The North Polar Cap is mostly water ice. The South Polar Cap contains a lot of frozen carbon dioxide. During winter, carbon dioxide from the atmosphere freezes onto the poles. During summer, it sublimates back into gas. This creates seasonal pressure changes in the atmosphere. That is something Earth does not experience. Mars has many dust-covered plains, but beneath the dust, radar has shown large amounts of frozen water. Some estimates suggest that if all the ice on Mars melted, it could cover the planet with a global ocean several meters deep. Not enough for Earth-like oceans, but enough to be extremely important for future missions. Water on Mars exists today mostly as ice, underground ice, very small amounts of vapor in the atmosphere. Liquid water cannot stay stable on the surface because of low pressure, low temperatures. It either freezes or evaporates almost instantly. However, salty water could exist briefly. Salts lower the freezing point of water. Some dark streaks observed on slopes were once thought to be liquid water. Today, scientists believe most of them are caused by dry dust flows, not water. Mars also has weather, even with its thin atmosphere. The wind on Mars can reach high speeds. But because the atmosphere is so thin, the force is weak. A strong Martian wind feels like a light breeze on Earth. However, that wind is strong enough to move dust. Dust storms are one of the most dramatic features of Mars. They can be local, regional, or global. Global dust storms can cover the entire planet and last for weeks or months. During these storms, sunlight is blocked, temperatures drop, solar-powered rovers lose power. In 2018, a global dust storm ended the Opportunity rover mission because its solar panels could not recharge. Dust storms are caused by temperature differences, strong winds, seasonal changes, sunlight heating the surface. Mars dust is very fine and stays suspended in the air easily. This dust also makes the Martian sky appear pink or orange instead of blue. Mars has a very thin atmosphere. Its average surface pressure is about 6 millibars. On Earth, the average pressure is about 1,013 millibars. That means Mars' atmospheric pressure is less than 1% of Earth's. This has huge consequences. First, liquid water cannot remain stable on the surface. At such low pressure, water either freezes or evaporates almost instantly. Second, humans cannot survive without a spacesuit, even with oxygen. The low pressure would cause bodily fluids to start boiling. This is called ebullition. You would lose consciousness in seconds. Mars' atmosphere is made mostly of carbon dioxide. Its composition is approximately 95% carbon dioxide, 2.7% nitrogen, 1.6% argon, 0.13% oxygen. Trace amounts of water vapor. This means no breathable air, no protection from radiation, very weak temperature regulation. On Earth, our thick atmosphere and magnetic field protect us from space radiation. Mars has neither. Mars once had a magnetic field, but it disappeared billions of years ago. When its core cooled, the magnetic field collapsed. Without it, the solar wind slowly stripped away the atmosphere. NASA's MAVEN mission confirmed this process by directly measuring how particles from the sun remove atmospheric gases from Mars. Because of this, Mars lost most of its air, most of its surface water, much of its ability to support life. Another important aspect is radiation. On Earth, radiation levels are low because the atmosphere blocks harmful particles. The magnetic field deflects charged radiation. On Mars, radiation levels are much higher. An astronaut on Mars would receive about 50 times more radiation than on Earth. Enough to significantly increase cancer risk over time. This makes long-term human presence extremely dangerous without heavy shielding. Habitats on Mars would need thick walls, underground placement, layers of Martian soil for protection. Now let's talk about the sky. On Earth, the sky is blue because air molecules scatter blue light more than red light. On Mars, the atmosphere is thin and full of fine dust particles. These particles scatter light differently. As a result, the sky is usually pink, orange, or yellow. Near the sun, the sky can appear bluish. This is the opposite of Earth. Sunsets on Mars are blue. Sunsets on Earth are red. This happens because Martian dust filters light in a different way. The temperature on Mars changes a lot between day and night. Because the atmosphere is thin, heat escapes quickly. There is little insulation. Day temperatures near the equator can reach about 20 degrees Celsius. Night temperatures can drop to -70 degrees Celsius or lower. That is a swing of almost 100 degrees in one day. Winds on Mars can reach speeds of 100 kilometers per hour. But because the air is thin, the force is weak. However, these winds can still move dust, cover solar panels, erode equipment. Dust is one of the biggest engineering problems on Mars. It is extremely fine, electrostatically charged, sticks to surfaces, hard to clean. It can damage solar panels, joints, instruments, seals. This is one of the reasons nuclear-powered rovers are preferred over solar-powered ones for long missions. Mars also experiences pressure changes with the seasons. In winter, carbon dioxide freezes at the poles. Atmospheric pressure drops. In summer, carbon dioxide returns to the atmosphere. Pressure rises. This creates a yearly breathing effect of the entire planet. Another danger is micrometeoroids. Because Mars' atmosphere is thin, small space rocks do not burn up. They hit the surface directly. For humans, this means habitats must be reinforced. Suits must be strong. Structures must be shielded. Mars is not immediately deadly like space vacuum, but it is extremely hostile to unprotected life. To summarize, no breathable air, low pressure, high radiation, extreme cold, large temperature swings, dust, micrometeoroids. All of these make Mars one of the most dangerous environments humans could try to live in. One of the biggest questions about Mars is simple. Was there ever life? Mars today is dry, cold, and mostly dead. But billions of years ago, the planet was very different. Evidence from orbiters and rovers shows that Mars once had rivers, lakes, possible oceans, standing bodies of water. Minerals like clay and hematite only form in the presence of liquid water. Their presence indicates that water existed for long periods, not just in short bursts. Scientists also look for biosignatures, signs of past or present life. These include chemical patterns in rocks, organic molecules, sedimentary structures that could only be formed biologically. Mars meteorites found on Earth also provide clues. Some contain tiny structures and chemical ratios that resemble microbial life. Though nothing is conclusive, the Perseverance rover, currently on Mars, searches specifically for ancient life in Jezero crater. Jezero has a dried-up river delta. Deltas on Earth preserve fossils very well, making them ideal targets. Perseverance collects rock samples and stores them in sealed tubes. Future missions may bring these samples back to Earth for detailed analysis. Scientists also study methane in the Martian atmosphere. Methane can be produced biologically or geologically. Seasonal spikes of methane suggest some active process, but we don't know if it's life or chemical reactions. Even if life existed, it is likely microbial. Single-celled organisms. No evidence yet suggests complex life ever developed. Mars also has harsh surface conditions. Intense UV radiation. Extremely low pressure. Toxic chemicals like perchlorates. This makes survival on the surface extremely difficult for any life today. Some scientists suggest that if life exists, it could be underground. Subsurface layers may protect microbes from radiation and retain liquid water. Finding life on Mars would answer one of humanity's biggest questions: are we alone in the universe? It would also inform us about the possibility of colonization. If microbes can survive, humans might be able to use similar strategies to grow crops or maintain habitats. Currently, the search continues with a combination of rovers, orbiters, and satellites. Rovers like Curiosity and Perseverance examine rocks and soil. Orbiters like Mars Reconnaissance Orbiter, (MRO), map the surface and detect minerals from space. Together, these missions build a picture of Mars' past and present. So far, the conclusion is, Mars was once wetter and warmer. It may have supported microbial life. Today, the surface is mostly uninhabitable. However, there are still plenty of mysteries waiting to be solved. Humans have been sending missions to Mars for more than 60 years. The first successful flyby was Mariner 4 in 1965. It sent back the first close-up images of Mars and showed that the planet was covered with craters and had a very thin atmosphere. In 1976, NASA sent Viking 1 and Viking 2. These were the first missions to land successfully on Mars. They performed experiments to look for life in the soil. The results were inconclusive. They did not prove life existed, but they also did not fully rule it out. In 1997, Mars Pathfinder landed with a small rover called Sojourner. This proved that mobile robots could explore Mars effectively. In 2004, NASA landed 2 rovers: Spirit, Opportunity. Their mission was planned for 90 days. Spirit worked for 6 years. Opportunity worked for almost 15 years. They discovered strong evidence that liquid water once existed on Mars. They found minerals that form only in water and rock structures shaped by flowing water. In 2012, NASA landed Curiosity. Curiosity is a car-sized rover with a nuclear power source. Its goal is to determine whether Mars ever had conditions suitable for life. Curiosity found organic molecules in Martian rocks, seasonal methane changes, ancient lake environments. This strengthened the idea that Mars was once habitable. In 2018, NASA landed InSight, a stationary lander. Its job was to study Mars' interior. It measured Marsquakes and confirmed that Mars is geologically less active than Earth. In 2021, NASA landed Perseverance. This rover is designed to search for ancient life, collect rock samples, prepare for future sample return missions. Perseverance also brought a small helicopter called Ingenuity. Ingenuity became the first aircraft to fly on another planet. It proved that aerial exploration on Mars is possible. Other countries are also exploring Mars. For example, the European Space Agency, China with its Tianwen-1 mission and the Zhurong rover, the United Arab Emirates with the Hope orbiter. Mars is now a global scientific effort. Now, the big question. Can humans live on Mars? Technically, yes. Practically, it is extremely difficult. The main problems are atmosphere. Mars has no breathable air. Humans would need fully sealed habitats and spacesuits. Pressure. The pressure is too low for human survival. Habitats must be pressurized like spacecraft. Temperature. Mars is extremely cold. Habitats must be insulated and heated constantly. Radiation. There is no magnetic field. People would need underground habitats, thick shielding, limited surface exposure. Exploring Mars is not about escaping Earth. It is about learning how rare and fragile Earth really is. Thank you for watching this video. Please consider subscribing and like this video. Goodbye.